I am Radhakrishna, mathematics teacher. We are going to continue our topic parabola. This is 5th lecture. First, let us revise a few points discussed in the last class. Equation of the chord of the parabola s is equal to 0, which is bisected at p x1 y1 is s1 is equal to s11. If the parabola is like this, if p x1 y1 is the midpoint of the chord, equation of the chord is given by s1 is equal to s11. This is not only for standard parabola, for any parabola. Next, equation of the chord of the parabola s is equal to 0, joining the points x1 y1 and x2 y2 is s1 plus s2 is equal to s12. Equation of the chord joining p of t1 and q of t2 is this, but you have to remember in this form. And all of you should remember this formula for slope of the chord joining the 2 points. Slope of the chord is what? 2 by t1 plus t2. Okay. And the next points are, if p of t1 and q of t2 are the extremities of a focal chord, then t1 t2 is equal to -1. This is a parabola. If a chord passes through the focus, it is called focal chord. If the endpoints are with parameters t1 and t2, the condition is t1 t2 is equal to -1. We have proved it. And the tangents at the extremities of the focal chord intersect at right angles. If you draw tangents at this point and this point, this angle will be 90 degrees. And converse is also true. Whenever two tangents are perpendicular to each other, the chord joining the points of contact is the focal chord. And foot of the perpendicular from the point of intersection, if two tangents are perpendicular, foot of the perpendicular from the point of intersection on the chord will be the focus. Next, here we have already one property that two perpendicular tangents intersect on directrix. So, tangents at the extremities of the focal chord intersect on the directrix. Next point is, harmonic mean between the segments of a focal chord is semi-latus rectum. I remember we have proved it, but once again, the harmonic mean between the segments of a focal chord is semi-latus rectum. Suppose this is a parabola, this is focus, PQ is a focal chord, S is the focus. Okay. Now, we can prove this kind of properties by using standard form of the parabola y square is equal to 4ax. So, let the parabola be y square is equal to 4ax. Okay. Now, if you take this point as p of t1, this point as q of t2, what is the condition? If p and q are ends of the focal chord, t1 t2 is equal to -1, this point. Now, harmonic mean between the segments of the focal chord is semi-latus rectum. What are the segments SP and SQ? SP is equal to, what is the formula for focal distance? We have already discussed in the previous classes. Focal distance of a point x1 comma y1 is x1 plus a mod. So, here what is x1? at1 square. So, it is at1 square plus a, or a into t1 square plus 1, focal distance of the point p of t1. Similarly, SQ will be a into t2 square plus 1. Now, t2 can be written as -1 by t1. So, it becomes a into 1 by t1 square plus 1 it is equal to T1 square A T1 square, sorry, A into T2 T1 square plus 1 by T1 square. Now take harmonic mean of SP and SQ. If the harmonic mean of SP and SQ is semi-lattice rectum, then SP semi-lattice rectum and SQ will be in GP, sorry, will be in HP. If semi-lattice rectum is the harmonic mean of SP and SQ, then SP semi-lattice rectum and SQ will be in HP. Then what will be the relation between these three? 1 by SP plus 1 by SQ is equal to 2 by semi-lattice rectum. What is the semi-lattice rectum of this parabola? Lattice rectum is 4A, semi-lattice rectum is 2A. So we have to prove this. If this is proved, then this statement is proved. Now what is 1 by SP plus 1 by SQ? 1 upon A into T1 square plus 1 plus 1 by SQ, T1 square by A into T1 square plus 1. Simplify, directly you will get 1 by A, it is proved. So these three are in HP, okay. And one more thing, this is the property of any conic, not only parabola, it is the property of parabola, ellipse and hyperbola also, okay. So in hyperbola and ellipse, in the next further chapters, we are not going to prove this, directly we will give the statement, okay. Now next point is the tangent at one end of a focal chord is parallel to the normal at the other end. Actually we have not yet started the normal, but you know the basic meaning of normal. If a curve is like this at a point P, this is tangent. If you draw a perpendicular line through P, it is called normal, okay. Now since this point is related to focal chord, we are explaining, I am explaining here itself. Suppose PQ is a focal chord, then if you draw tangent at P and draw the normal at P, these two will be parallel. Tangent at P will be parallel to the normal at Q. How? You can easily prove it. Suppose this point is P of T1, this point is Q of T2. What is the condition? T1 T2 is equal to minus 1. What is the slope of the tangent at P of T1? We know that equation of the tangent at T1 is x minus T1y plus a T1 square is equal to 0. Everyone must be very thorough in all the formulae, like equation of the tangent, equation of the chord, etc. This is the equation of the tangent at P, then slope of the tangent is 1 by T1. Similarly, at Q, slope of the tangent will be 1 by T2, so slope of the normal will be minus 1 by T2. Sorry, slope of the tangent is 1 by T2, slope of the normal will be minus T2. Is it not? Slope of the tangent is 1 by T2, so slope of the normal will be minus T2. Now minus T2 is equal to what? 1 by T1, and that means this and this are parallel. It is proved. Next, the tangents at the ends of focal chord intersect on the directrix at right angles to each other. Already we have discussed about this point. Next is circle on the focal chord as diameter touches the directrix. take a focal chord, this is focus, draw a circle with the focal chord as diameter. Okay. This circle touches the directrix. So, directrix will be a tangent to the circle. Okay. How to prove it? We know that if the tangent at P intersects the directrix at T, we have already discussed that this angle is pi by 2, and if you draw tangent at Q, it will also intersect the directrix at T only, because if tangents intersect on the directrix, they intersect at right angles. This angle is pi by 2. So, if you draw a circle with PQ as diameter, that circle contains the point T and it touches the directrix. Okay. Next point, circle on the focal radius as diameter touches the tangent at vertex. If S is the focus, take any point P, then SP is called focal radius. If you draw a circle with SP as diameter, like this, tangent at vertex will be touching this circle, or circle touches the tangent at vertex. The proof is very simple. You draw the tangent at P, and we know that foot of the perpendicular from the focus on any tangent is on tangent at vertex. So, this is foot of the perpendicular. If this is say R, it is foot of the perpendicular from the focus. So, this angle is pi by 2. So, clearly the circle with SP as diameter touches the tangent at vertex at point R. Next point, equation of the pair of tangents from P x1 y1 to the parabola S is equal to 0 is S1 square is equal to SS11. Actually, we do not use this result at all except in very rare problems, and we have already discussed this result in circle. In notation, in all curves, the formula for pair of tangents will be same. If P x1 y1 is an external point, parabola is S is equal to 0. It may be in the standard form or general form. The equation of this pair of tangents is given by S1 square is equal to SS11. So, since we have already proved it in circle, take the result directly. Not only this curve, in ellipse and hyperbola also the formula is going to be same. Now, we are going to solve some questions on this theory discussed so far. First question, a circle of radius r intersects the parabola y square is equal to 4ax at A and B, which are extremities of diameter above the x axis and also touches the x axis. Then what is the slope of the chord AB? Actually, this was a previous JEE question. Take a parabola like this. The axis of this parabola would be like this. Y square is equal to 4ax is standard parabola, vertex is origin, axis is x axis. Now A and B are extremities of the diameter of a circle. Circle with AB as diameter touches the x axis. Axis of the x axis of the parabola means x axis. So I will take AB like this, given that it is above the x axis. Okay. With AB as diameter, I will draw a circle. Thus, this circle touches the x axis. Okay. Then, what is the slope of the chord AB? Radius of the circle is given R, and what else is given? Parabola is given, that is all. So, we have to get the slope of AB in terms of A and R. Let us assume A and B parametrically as T1, T2. If a circle touches the x axis, then y coordinate of the center will be equal to radius of the circle, is it not? So, from here this height will be y coordinate of the center, it is equal to radius of the circle r. But what is the y coordinate of the center? It is the midpoint of AB, because AB is the diameter of the circle. Y coordinate of A is 281, y coordinate of B is 282. So, y coordinate of the center will be 2AT1 plus 2AT2 by 2 is equal to R. Then you will get A into T1 plus T2 A into T1 plus T2 is equal to R. Okay, keep it like this. Now what do you want? Slope of the chord AB. Already we have discussed in the theory equation of the chord joining T1 and T2 and slope of the chord joining T1 and T2. Slope of AB is, what is the formula? 2 by T1 plus T2. What is T1 plus T2? R by A. If you substitute R by A here, you will get 2A by R. So, slope of AB is 2A by R. Fourth option is correct. Okay. Next question. The points A, B, C, D on a parabola are concyclic. Then the centroid of ABCD lies on axis of the parabola, tangent at vertex, directrix, latus rectum. 4 points on a parabola are concyclic. Equation of the parabola is not given. So, we will take standard form y square is equal to 4ax. Let this be the parabola, y square is equal to 4ax. 4 points are concyclic means a circle passes through those 4 points. So, I will draw a circle intersecting the parabola at 4 points. Now, let us take these 4 points as A, B, C, D. Let us take the points with parameters T1, T2, T3, T4. If the 4 points with parameters T1, T2, T3, T4 are concyclic, there must be some relation between T1, T2, T3, T4. Let us find it. To find that relation, assume that the circle is, equation of the circle is S is equal to x square plus y square plus 2gx plus 2fy plus c is equal to 0. Let the circle be x square plus y square plus 2gx plus 2fy plus c is equal to 0. Circle passing through ABCD. There are 4 points on this circle which are in the form of at square to at. Okay, this is at1 square to at1, this is at2 square to at2 and so on. So, there are 4 points on this circle which are in the form of at square to at. So, I will substitute at square to at in this equation. Substituting at square to at, you will get a square t power 4 plus 4 a square t square plus 2 ga t square plus 4 fa t plus c is equal to 0. This is a 4th degree polynomial equation in T. What are the 4 roots of this equation? This equation must have 4 roots because degree is 4. Those 4 roots of this 4th degree equation are nothing but T1, T2, T3, T4. Okay. Then you notice this equation, in this equation T cube coefficient is absent. When T cube coefficient is absent, then sum of the roots of this 4th degree equation will be 0 because sum of the roots of a polynomial equation is minus of coefficient of 3rd degree term by coefficient of 4th degree term. So, T1, T2, T3, T4 are the roots, then sum of the roots is T1 plus T2 plus T3 plus T4 is 0 because T cube coefficient is 0. So, this is the relation between the parameters. Okay. Now, centroid of ABCD lies on, what is the formula for centroid of 4 points? Sum of the x coordinates by 4 comma sum of the y coordinates by 4. So, the centroid is a t1 square plus a t2 square plus a t3 square plus a t4 square by 4. This is x coordinate. Y coordinate is 2a t1 plus 2a t2 plus 2a t3 plus 2a t4 by 4. This is y coordinate. You can directly observe that y coordinate will be 0. If you take 2a common, 2a into t1 plus t2 plus t3 plus t4 is 0. If the y coordinate is 0, whatever be the x coordinate, it always lies on x axis. X axis is what? Axis of the parabola. Is it not? So, answer is option A, option 1. And also I suggest you to note down this formula, this as a formula in theory. If a circle intersects the parabola y square is equal to 4ax at points with parameters t1, t2, t3, t4, then sum of the parameters is 0. In future problems directly we will apply this result. Okay. Find the length of the focal chord of y square is equal to 4ax whose one end is p of t. Actually this and these both the results must be remembered by students. Take a focal chord of the parabola whose one end is p of t. Then this is focus. We have to find the length of the focal chord in terms of t. Let us assume that the parameter of Q is T dash, then what is the relation between T and T dash? T into T dash is equal to -1. Now, length of the focal chord we want PQ. We can write PQ as SP plus SQ. I am taking magnitudes, they are not signed distances. If they are signed distances, SP and SQ will have opposite signs. So, I am taking mod SP plus mod SQ. What is mod SP? I have already discussed the focal distance formula. It is mod x1 plus a, that is mod a t square plus a, that is a into t square plus 1, is it not? Plus, what is SQ? A into t dash square plus 1. Now, let us write T dash as -1 by T. Then, you will get T dash square as 1 by T square plus 1. Now, let us add. You can observe that this is A into 1 plus T square by T square. So, we can take A into 1 plus T square common. A into T square plus 1 is common. Remaining will be here 1 plus here 1 by T square will be remaining. Then again taking T square LCM, you will get A into T square plus 1 whole square by T square, but it is better to remember this as A into T plus 1 by T whole square. Take this as a formula. Length of the focal chord whose one end is with parameter T is A into T plus 1 by T whole square. Now, coming to next question. If the focal chord makes an angle theta with the axis of the parabola, then what will be the length of the focal chord? This time, if theta is the inclination of the focal chord with the axis, then slope of the focal chord will be tan theta. So, tan theta is equal to, what is the formula for slope of the chord joining T and T dash? 2 by T plus T dash. Then we will get T plus T dash is equal to 2 cot theta. 2 by tan theta is 2 cot theta. We already have T dash is equal to -1. Now, what do you want? Length of PQ. Okay. Already we have proved that length of PQ is this. Okay. A into T plus 1 by T whole square. I will write 1 by T as minus T dash. Then the length of the focal chord is A into T minus T dash whole square. T minus T dash whole square can be written as T plus T dash whole square minus 4 T dash. Substitute T plus T dash and T dash. You will get A into, this is 4 cot square theta, T1 T dash is -1, so plus 4. Taking 4 common, cot square theta plus 1 is cosecant square theta, so it becomes 4A cosecant square theta. All of you should remember this as a formula. Please note it separately. Length of the focal chord of any parabola whose inclination with the axis is theta is 4A into cosecant square theta, where 4A is length of the lattice rectum. Next question. find the locus of the midpoint of chords of y square is equal to 4ax which are tangents to the circle x square plus y square is equal to a square. That is one question. Another question is which subtend a right angle at vertex. I will solve first question. Parabola is like this with the origin as vertex for y square is equal to 4ax. How is the circle x square plus y square is equal to a square is a circle with origin as center and a units as radius. So that circle will be like this. Now we want locus of the midpoints of the chords of the parabola which are tangents to the circle. So draw a tangent to the circle, any tangent. This is a tangent of the circle. Then it will have a midpoint now. Let P be the midpoint. As this tangent is changing, P will be moving. So P traces a curve. That curve is locus of P. So this is the diagram. Now how to find the path of P or locus of P? Let us take P as x1 y1. In any locus problem, usually we take P as x1 y1 on the locus and apply the conditions. If P x1 y1 is the point on the locus, then P is the midpoint of the chord. Then what is the equation of the chord? If P x1 y1 is the midpoint of the chord, equation of the chord is given by, what is the formula? S1 is equal to S11. Okay. What is S1? y1 minus 2a into x plus x1 is equal to y1 square minus 4a x1. Cancel minus 2a x1 on both sides. You will get y1 minus 2ax is equal to y1 square minus 2a x1. Now this chord is a tangent of this circle. So this line is a tangent to this circle. If a line is a tangent to a circle, what is the condition? Perpendicular distance from the center is equal to radius. So what is the center of the circle? Origin, radius is a. So perpendicular distance from the center, perpendicular distance from origin should be equal to radius of the circle a. What is the perpendicular distance from the origin to this line? All of you know the formula for perpendicular distance from the origin. Mod c by root a square plus b square. Mod c means term independent of x and y. This one. Mod y1 square minus 2ax1 by root over y1 square plus 4a square. Should be equal to a. Now cross multiplying and squaring, y1 square minus 2ax1 whole square equals a square into we got the relation between the coordinates of P. After getting the condition on x1 and y1, what will you do? Locus of P is given by replacing x1 by x and y1 by y. Therefore, locus of P is y square minus 2ax whole square is equal to a square into y square plus 4a square. So, this is the answer to the first question. Now, I will solve the next question, second part. Again, find the locus of the midpoints of the chords of the parabola y square is equal to 4x which subtend a right angle at vertex. Take a parabola. If a chord subtends a right angle at vertex, what is the vertex of the parabola? Origin. So, this angle is pi by 2. Then we have to find the locus of this midpoint. Let P x1 y1 be the midpoint of the chord. We can solve it in two methods. Method 1. Method 1. Equation of the parabola is y square is equal to 4ax. What is the equation of the chord? We have seen in the previous question, previous question. This is the equation of the chord now. So, let us write it here. The chord is y1 minus 2ax is equal to y1 square minus 2ax1, that is the equation of the chord, and this is origin. If this line intersects the parabola at A and B, then how to get the pair of lines joining the points of intersection of this curve and this line and the origin? You must have studied homogenization of a curve and a line. When the equation of a curve and equation of a line are homogenized, you will get the equation of the pair of lines joining the points of intersection and origin. So, I will homogenize these two. This is 1, this is 2. Homogenizing 1 and 2. Homogenizing the equations 1 and 2. Take the parabola y square minus 4ax is equal to 0 is the equation. You will keep the second degree term as it is. The first degree term should be multiplied by what? Taking this constant term to this side as denominator, RHS becomes 1. We will multiply this first degree term by y1 minus 2ax by y1 square minus 2ax1. This is called homogenization of this curve and this line. Now, simplify it. Multiplying by y1 square minus 2ax1, this into y square minus, multiply these two, 4a y1 into xy plus 8a square x square is equal to 0. This equation is in the form of ax square plus 2hxy plus by square is equal to 0, which is a pair of lines through the origin. This is the pair of lines joining the origin and the points of intersection A and B, and the angle between this pair of lines is pi by 2. If angle AOB is equal to pi by 2, then if the angle between pair of lines is pi by 2, all of you are aware of the condition, x square coefficient plus y square coefficient is 0. So, y1 square minus 2ax1 plus 8a square, coefficient of y square plus coefficient of x square should be 0. Then how to get the locus? replace x1 by x and y1 by y. So locus of P is y square minus 2ax plus 8a square is equal to 0. This is method 1. Now let us see the method 2. In this method, again take the diagram. This angle is pi by 2. I will take P and Q parametrically, P of T1, Q of T2. P of T1 means AT1 square to AT1, Q of T2 means AT2 square to AT2. Now, what is the slope of OP? Slope of OP, this is origin, this is AT1 square 2AT1. What is the slope? 2AT1 minus 0 by AT1 square minus 0. What you will get? 2 by T1. Similarly, slope of OQ is 2 by T2. If OP is perpendicular to OQ, what is the condition? Product of the slopes is minus 1. So, this into this, 4 by T1 T2 is minus 1. So, we will get T1 T2 is equal to minus 4. Now, this is the only condition we have. Using this condition, we have to find the locus of this midpoint. Let this midpoint be R x1 y1. Then x1 is equal to a T1 square plus a T2 square by 2, that is a into T1 square plus T2 square by 2 x1. y1 is equal to 2a T1 plus 2a T2 by 2, that is a into T1 plus T2. Now, we have to eliminate T1 and T2 using this condition and get the direct relation between x1 and y1. What we will do? Let us square this second y coordinate. y1 square is equal to a square into T1 plus T2 whole square is what? T1 square plus T2 square minus plus 2 T1 T2. T1 square plus T2 square is 2x1 by a. Substitute a square into 2x1 by a plus 2 T1 T2 is minus 8. This is minus 8. Then multiplying by a square inside, you will get 2a x1 minus 8a square. So, we got the condition, replacing x1 by x and y1 by y, see we get the same equation, same locus. So, this method is looking good. Next question, find the midpoint and length of the chord x minus 2y minus 4 is equal to 0 of the parabola y square is equal to 4ax. Equation of the chord is given. equation of the chord is given as x minus 2y minus 4 is equal to 0. We have to find midpoint of the chord, say P, and length of the chord also. Let the ends of the chord be A and B. Then we need to find length of AB and coordinates of P. Okay. First, finding the midpoint. Let us take P as x1, y1. Then what is the equation of the chord according to our formula? S1 is equal to S11. S1 is equal to S11 is y1 minus 2 into x plus x1 is equal to y1 square minus 4x1, equation of the chord. Cancelling minus 2x1, we get y1 minus 2x is equal to y1 square minus 4x1. We can write it as 2x minus y1 plus y1 square minus 4x1 is equal to 0. This is the equation of the chord with midpoint x1, y1. But equation of the chord is already given. So this equation and this equation must be same. So comparing this and this, what we will get? Comparing two lines means if two equations represent same line, then the coefficients of x must be equal to coefficients of y must be equal to ratio of the coefficients of x must be equal to ratio of the coefficients of y must be equal to ratio of the coefficients of constant term. So I will take 2 by 1 is equal to minus y1 by minus 2 is y1 by 2 is equal to y1 square minus 4x1. Is it 4x1? After cancelling 2x1, this is not 4, it is 2 here also. y1 square minus 2x1 by minus 4. Then we get y1 is equal to 4, 2 into 2 4. Then equating this and this, we get y1 square minus 2x1 is equal to minus 4 into 2 minus 8. Substitute y1 here, 16 minus 2x1 is equal to minus 8. So 2x1 is equal to 24, x1 is equal to 12. So the coordinates of the midpoint are 12, comma 4. First part is over. Now second part. We have to find the length of the chord. Let us assume that one end is T1, another end point is T2. Then what is the distance between A and B? AB is equal to, applying distance formula, square root of A square into T1 square minus T2 square whole square plus 2a T1 minus 2a T2 whole square will be 4a square into T1 minus T2 whole square. You can see a square is common, and if this is factorized as T1 plus T2 into T1 minus T2, T1 minus T2 whole square will also be common. So taking a square and T1 minus T2 whole square outside, you will get a into mod T1 minus T2 into square root of T1 plus T2 whole square plus 4. Now, equation of the chord is given. Comparing with the equation of the chord joining T1 and T2. What is the equation of the chord joining T1 and T2? 2x minus of T1 plus T2 into y plus 2a T1 T2. A is 1, so 2 T1 T2. This is the equation of the chord joining the points T1 and T2. Then compare them. What will get? 2 by 1 is equal to T1 plus T2 by 2 is equal to 2 T1 T2 by minus 4 is T1 T2 by minus 2. Okay. Now, substitute here. A is 1. In the parabola, A is 1. Now, mod T1 minus T2. How to calculate mod T1 minus T2? Here T1 plus T2 is 4 and T1 T2 is minus 4. Then T1 minus T2 whole square is T1 plus T2 whole square minus 4 T1 T2. How much? 16 plus 16. 32. Then T1 minus T2 is root 32 is 4 root 2. Next, this one root over 4 square plus 4. 4 square is 16, 16 plus 4 20. Root 20 is 2 root 5. So, answer is 8 root 10. Length of the chord is 8 root 10. Next question. The orthocenter of the triangle circumscribing a parabola lies on axis, tangent at vertex, directrix, latus rectum. First you should know what is the meaning of circumscribing the parabola. First, if you take a circle, draw a circle touching, if you take a triangle and draw a circle touching all sides inside, lying inside, then we say that circle is inscribed in the triangle or triangle is circumscribing the circle. Okay. Triangle is circumscribing a circle means triangle is formed by the tangents of the circle. If a triangle is formed by 3 tangents of the circle, then triangle is circumscribing the circle. Similarly, here triangle is circumscribing the parabola means triangle is formed by 3 tangents of a parabola. So, I will take 3 tangents of the parabola at A of T1, one tangent, at B of T2 and C of T3. And we know the formula for point of intersection of the tangents. Point of intersection of the tangents at T1 and T2 will be, say, P. P A T1 T2 comma A into T1 plus T2. Similarly, point of intersection of the tangents at T2 and T3. This is, say, Q. Q is A T2 T3 comma A into T2 plus T3. Similarly, this is R A T1 T3 A into T1 plus T3. Actually, equation of the parabola is not given. In such cases, we assume that parabola is y square is equal to 4ax and get the answer. Okay. If anything is proved for y square is equal to 4ax, it will be true for all parabolas. That is why we are studying the simplest form or standard form. So, orthocenter of this triangle lies on which of these four? Let us find the orthocenter. For finding the orthocenter, we have to find the equations of any two altitudes. I will find out altitude from P. Altitude from P will be perpendicular to opposite side. Similarly, altitude from Q will be perpendicular to this opposite side, and their point of intersection is orthocenter. Okay. For finding the equation of this altitude, you have a point. What else you need? Slope of the opposite side. Slope of this line is what? What is this line? This is tangent at T3. Slope of the tangent at T3 is 1 by T3. So, what will be the slope of this perpendicular line? If the slope of this line is 1 by T3, slope of this line will be minus T3. Therefore, equation of the altitude from P will be equation of the altitude from P is using point and slope, y minus a into T1 plus T2 is equal to, what is the slope of the altitude? Minus T3. Minus T3 into x minus a T1 T2. Okay, we can write this as taking the negative terms this side, you can write T3x plus y is equal to a into T1 plus T2 plus a T1 T2 T3. This is equation of the altitude from P. Then directly you can write the equation of the altitude from Q. How? Changing T1 to T2, T2 to T3, T3 to T1. So, altitude from this will be T3 becomes T1, T1 becomes T2, T2 becomes T3, and this remains as it is because all three are present. This is the altitude from Q. How do you get the orthocenter? By solving these two. Solve. If you subtract directly, y is cancelled out. Subtract T3 minus T1 into x is equal to a into, subtract T1 minus T3. This is cancelled. Then you will get x is equal to minus a. It is independent of T1, T2, T3. So, x coordinate of the orthocenter is constant, independent of points T1, T2, T3. And clearly, this is the equation of directrix of the parabola. Is it not? That means, for any 3 points, the orthocenter of this triangle lies on the directrix. Answer is option 3. Okay. Next question. The vertex A of parabola y square is equal to 4ax is joined to any point P on it. PQ is drawn at right angles to AP to meet the axis at Q. Then the projection of PQ on the axis is. take the parabola like this. He said vertex is A. Actually A is origin. Vertex is joined to any point P. Okay, any point P on the parabola. PQ is drawn at right angles to AP. Perpendicular to AP, PQ is drawn, means Q is the opposite end of the chord. Okay. To meet the axis at Q, not this one. PQ is drawn at right angles to AP to meet the axis at Q. So this is not Q. This is Q. Okay. Then the projection of PQ on the axis is, projection means you should draw a perpendicular like this. This is called projection. We have to find its length. Okay. Now this is origin. As usual, we take P as AT square to AT. Okay. Now, what is the slope of OP? Not OP, it is AP. Slope of AP is 2 by T. Then what is the slope of this perpendicular line? It will be minus T by 2. Slope of PQ. If the slope is 2 by T, slope of the perpendicular line will be minus T by 2. Okay. Now, what do you want? Projection. To find this projection, write the equation of this PQ. What is the equation of PQ? Y minus Y1, Y1 is 280, is equal to T by 2 into X minus AT square. Okay. Then what will get? 2y minus 4at is equal to tx minus at cube. Now, what is its point of intersection with the x axis? Put y is equal 0. Putting y is equal 0, we get tx minus at cube is equal to minus 4at. Okay. So, x is equal to at square minus or plus at square minus 4a. Okay. What is this x? It is AP. AP is equal to at square minus 4a. AQ, sorry. X coordinate of Q is nothing but AQ, just some sign problem is there. Slope of PQ is minus T by 2 now. So, this is minus, so this is minus, this is plus. So, then putting y is equal 0, you will get Tx minus AT cube is equal to plus 4AT. Okay. So, that is what AQ. Now, you want this projection, this is nothing but x coordinate of P, that is AT square. So, how do you get this projection? Projection is AQ minus AT square. AQ minus AT square is equal to what? 4A. That means wherever you take P and proceed like this, drawing a perpendicular, this projection will be a constant 4A. Okay. Answer is third option. Okay. So, with this I am going to close the session. That is it for today. Thanks for watching. See you in the next class.